We've been talking about design, right? And so the pattern we're going to cover today is called the Composite Pattern. This is one of the 3 patterns that you're going to be responsible for. The one we're going to cover next is going to be Iterator, and that's going to be the last one. So that's on Friday. So today and Wednesday, we'll cover the Composite Pattern and practice it as well. So there's a lecture lab that we're going to start today, hopefully, and then probably spend all of Wednesday working on it. Now, just as a reminder, course evals are due. So you should have all received emails about course evals. So please fill those out. Those would be really helpful to me. And then in labs this week, all of you are going to sign up for demos for the project. So there's going to be a schedule where all of you are going to be responsible for coming into labs at a specific hour, specific time, to demo your project. Okay? And so you should make sure to go to lab this week to sign up for those. And then finally, projects are due Monday. So even though your lab might be on Tuesday, it might be on Friday, so you think you have extra time to work on your project? Well, you do not. So everything is due on Monday. Okay, so at the time that the TA is checking your project, they'll make sure that the timestamp of the SVN checkout that you're using is dated Monday or before Monday. Okay, so let's talk about composite pattern. So here's a nice diagram from Wikipedia that sort of describes this pattern. This pattern is a little bit more abstract than the previous pattern that you've seen. And the key to understanding this pattern is to reason about hierarchies. Okay, so this pattern is typically applied in cases where you have some kind of tree, a tree of objects, like a file system. So like when you open your Finder window or your Explorer window, there's a tree of directories and files. And that tree, if you want to represent it in a programming language, one of the simplest ways to do so is to use the composite pattern. Okay, so this Uml diagram basically describes it where you have some abstract component, and this abstract component has some operation. So this operation doesn't necessarily have to be named operation, and it could have multiple such operations. Right? It just has some abstract notion of an operation. And what you're trying to do is build a tree that contains essentially versions of this leaf. So like a tree of files and directories. And you need to, in the tree you have a node that will essentially reference other pieces. So if you have a directory, if I have a directory structure, I'm going to have dir that has some file A, and then I have another directory, directory 1, directory 2, that's going to have file B, and so forth, right? So this is a structure in which you have objects like dir2 is actually an intermediate node. It's a node composed of other nodes. And then in this tree you also have leaves. Like file A is a leaf here. Your tree terminates at that leaf. So for you to express this structure in your Java program, you would use this pattern. And the idea is that you would have some nodes that are leaf nodes, so they just implement this specific operation. And then you have some other nodes that are going to be composite nodes. And they're composite in the sense that they aggregate multiple components. So a directory aggregates multiple leaves as well as multiple other composite nodes. So directory 2 may contain directory 3 and so on. So a composite node references 0 more components. Okay, so a composite may contain another composite node. Composite node may contain multiple leaves. And so the composite node has, also implements versions of this operation, but also has a bunch of operations, a bunch of methods for dealing with its set of components. So you can add a new component. That would be like adding a new file or a directory. You could remove a component. So that would be removing a file, removing a directory. And you could just find out what the children are of a component, of a composite. Okay, so in the abstract, this is what this pattern looks like. So we're going to look at the specific instantiation of this pattern in the composite drawing editor starter. So if you have your laptops, you should check this project out. And we're going to go through. We're going to do something very similar to what we did last time with the alarm system, where we're going to essentially extract the UML diagram from the code, and then think about how we're going to implement this pattern in this code base. So if you look at the starter code, the starter code is your favorite drawing editor. So if I run this as a Java project, I get some very simple drawing editor. So I can create a rectangle, I can create an ellipse, just do very basic things, right? And there's one additional kind of tool on the side here, which is the grouping tool. So I may want to select multiple objects and then group them, and then do some operation on the group. So currently this tool is not implemented, so if I try to move a group, well, it just moves the individual node. Right, so what we want to achieve is a grouping property whereby I select multiple of the figures that I drew and then act on them as a whole. Right, so for example, if I wanted to move the group as a whole. So this is the project. This is kind of our little pet project that we're going to experiment with. And so the project has some very basic elements that you've seen before. So I'll briefly go over them. And here's the reconstructed UML diagram that I put together for it. And this is not exact. I don't have everything on there, but this should give you an idea of approximately what the project is. So I have a notion of a drawing, right? Or maybe let's start with the drawing editor. So a drawing editor is this class. It knows about multiple drawings. It knows about multiple tools, right? So I have a drawing editor, and it aggregates drawings and tools. And then tools, they have a hierarchy, right? So, and there's even a sub-package for tools, where I have a tool, which is just an abstract class, represents a tool that has a button. It's either active or it's not. It knows about the editor. So this is not unidirectional, it's bidirectional. And then there's a bunch of tools, like the ellipse tool, the circle tool, and so forth, right? So there are a bunch of tools that actually extend this abstract class tool and then make tools. So for us, the more interesting part of the diagram is going to be on the right. So if I look at drawing, my drawing knows about multiple figures, and a figure is an interface. So a figure has multiple operations, like you can draw the figure, you can figure out if a point is inside of a figure, you can translate it, move it across, you can select it, and so forth. So a bunch of these operations that are not implemented within this interface, they're implemented partially within the abstract figure. So abstract figure implements this figure interface. And down below, you're going to have circle, rectangle, and all these figures that you can add to the project. So if I wanted to create a notion of a composite figure, of a group of figures, how would I go about doing this? What do you guys think? So if I wanted to add a figure, a new figure, right? How would I do this?
Would you create a class composite figure and have it as the two figures?
And have an arrow to where? To abstract figures? Well, okay, all of you should know the answer to this. This is kind of sad. Come on, guys. So if I'm adding a new figure, right? I'm adding a new class to the project called figure, right? And the name should give it away, right? So it's a figure. So it belongs somewhere in this hierarchy, right? It's a composite figure. So it needs to be concrete, because I'm going to create it. So it's somewhere down here. So essentially what I'm getting at is that, first off, if you think about this task of adding a composite figure, one that groups together multiple figures, your first reaction is to add it here. Right? You're adding a new figure type. You're going to say it's a composite figure. It knows about multiple figures. So what? It's just another kind of figure. Right? So the first step is to really think about, okay, I'm going to add it to this hierarchy here. So unfortunately, this would be a big mistake. Right? And I'll show you why in code. So if you look at the selection tool, the selection tool has, the selection tool deals with figures, right? It selects figures. That's all it does. So the current code right now, like down below, essentially, let's look at the mouse pressed in drawing editor. So if you look at this code, what it does is it says, well, editor, get figure in drawing. If I have some figure, right? If my figure is selected, then if my figure is not selected, then I'm going to select it. Otherwise, I'm going to unselect the figure. And then there's some kind of validation step here. So there's a mouse event. The mouse event is at a particular point, and then I'm going to get the figure at that point, and then I'm going to ask, is this figure selected or is it not selected? Okay, so this is simple enough, and this works for all kinds of figures. Right? So this code is not specific to the rectangle. It's not specific to the ellipse. It works just fine as long as you can call a method, figure.select, and you can evaluate whether a point is inside a figure. So if I wanted to add a new kind of figure, like the composite figure here, and the code is it's not filled in, but essentially you want to extend abstract figure. So let's think about how you would implement mouse pressed in drawing editor for a composite figure. How would I need to change this code for a composite figure? So my composite figure contains multiple figures. So I want to make sure that if I select the composite figure with the selection tool, then I select all of the figures inside of the composite figure. That's kind of the behavior that you would consider to be natural, right? So how would I do this? Would this just work? Would it work to call figure.select? So let me give you the pseudocode that I wrote for it. And here it is in all its ugliness. So this is the same method, except that I'm writing code for the composite figure. And note that instead of just calling figure.select when my figure is not null and it's not selected, I'm actually going to check whether it's a composite figure. And if it's a composite figure, then I want to iterate through all the figures that the composite figure knows about, right? And then select each one of them in turn. Otherwise, it's a normal figure, so I just select the figure. And then if I want to deselect the figure, then I have to do something very similar where I have to say, well, if it's a composite figure, then I have to treat it specially. Right? Because it's not just a figure, it's a collection of figures. There I have to make sure to unselect all of the figures that it contains. Okay, so this code reflects what would happen if you were to go with a design that look like this, where the composite figure simply extends the abstract figure. And this is problematic, right? So before I had this really nice, clean code right above here, where all of my figures were treated equally. But now, because I have this hierarchical relationship, where I want my composite figure to be composed of multiple figures, I have to special case my code. So when I say special casing my code, I mean that I have to write a specific bit of code to handle the composite figure. And if I have any other object in my system that behaves in some strange way, I would need to do that for that object. So eventually my system will evolve to be this huge mess of spaghetti code. That's a technical term. Right? So my code would get more and more complicated because I am treating this composite figure as a different kind of object. Okay? And you can see that in the code. So this pattern essentially changes all this and cleans up the code. So here's the design according to the composite pattern. And in the composite pattern, I'll bring it up here as before. Right, so the idea here was I have some component, I have some operation, I have a composite which aggregates multiple components. So I'm going to have an edge back to component. Okay, so this is what I have here. I have a composite figure. Instead of just being an abstract figure, it's now going to aggregate multiple figures. And this aggregation will be really important. Oh, and actually, I'm missing a line. So it still extends abstract figure. Okay. So in the composite pattern, this composite object, it is treated as if it's any other figure. And then the key observation is that it also aggregates a bunch of figures. So to see how this, what this looks like, take a look at the composite drawing editor complete. So this is a different project. And in this project, we've added the composite figure as a composite object. And so first of all, I'll demo for you that it actually properly works. So I can select a rectangle, create a second rectangle, select them, group them, and then move them together, right? So this was my desired behavior, right? Hooray, I get my point, right? So my moving tool figured out that I'm actually clicking on a composite figure, and it moves the entire group, right? So let's look at the code and how this pattern is generated in code. So I have this composite figure. It extends abstract figure, as the Uml diagram says, and it has a bunch of figures that it knows about. Now, this composite figure will implement all of the operations of my figure interface in this case. So my figure interface tells me that I need to know how to draw the figure, I need to know about containment of a point in the figure, and all these other things. So my composite figure will implement all of these operations. And the way it will implement them is simply by iterating through its internal set of figures. So if you think about what happens if you were to call draw on a collection of figures, well, it just means that I have to call draw on each of the individual figures that are composed into this larger figure. If I want to check containment, then I'm just going to check containment for each individual figure. If I want to translate the entire group, then I'll translate each of the individual figures. So in this case, it's really, each of these operations is pretty straightforward. They're passed in kind of through to the set of figures on an individual basis. But the nice thing here is that the selection tools, all of the tools, like we can start with the selection tool. The selection tool, and in particular this mouse pressed and drawing area method, hasn't changed at all. right? Because now my figure might be a composite figure, but it might be something else. It might be a circle or rectangle. But they behave the same, right? Because when I do figure.select, my composite figure will figure out how to do selection. So selection is down here, so this is what it will do. And if my figure happens to be an ellipse, then my selection will work as if, as an ellipse is supposed to work, which is probably an abstract figure somewhere. So here's my selection. Okay, so the advantage of the composite pattern is that it allows me to treat objects that are composite nodes in a tree as if there were leaves, identically. So even though this node is an aggregation, like a directory, I can still treat it as if it's a file. Right? And the same operations will work on it because it's implemented as a composite pattern. You guys have questions about that? That's confusing. So here, I'll bring up the Uml diagram once again. So composite figure extends abstract figure. And it's a node that knows about other figures. So there's this aggregation relationship. Because it itself is an abstract figure, my tools, which work on figures, can work on my composite figure. So it becomes really straightforward for me to implement all of the operations that figure implements inside of the composite figure. Right, so the way that it implements selection is by iterating over the figures that it knows about and selecting each of them. Or the same thing for drawing. I draw each of the figures that are inside of my composite figure, and so forth. Yeah?
If we were going to look at it like with the directory and file thing that you were writing before, would we consider abstract figure to be the directory and then composite figure to be a directory within that? Like,
yeah, I think in the...
That?
So you're asking about the analogy of how this would look for files, right?
Yeah.
Yeah, so for files, this would look like, I'd have a notion of a file. Let's see this. Maybe I should do this on a separate piece of paper. So for a file system, I'd have a notion of a file. And then I would have, so this would be an interface, say, and I would have abstract file. An abstract file will implement things like, the size of the file, for example, or the name of the file. So those operations, like get file size, get file name, can be inside of this interface or file. And of course, all of those operations make sense for a directory as well. Right? You can still get the name of the directory and the size. And so down below, I'll actually start extending abstract file to be, I don't know, maybe text file. Maybe I have a JPEG file. I have different kinds of files, and they have, maybe there's different ways in which I write them, different ways in which I read them. So I need individual classes to represent these. And then the way I would use the composite pattern to create a directory is I would say, well, a directory is actually just an abstract file. Right? There are ways in which I read directories. There are ways in which I write directories. I can get a size of the directory, and so forth. Except that a directory is actually composed of multiple files. And this is where the aggregation relationship comes in. So I need to actually aggregate a bunch of files in my directory. So a directory may be empty, but it can also have n files. Right? So it would look something like this. Yeah?
Why do we extend the abstract and then aggregate the interface?
Yeah, why do we extend the abstract and aggregate the interface? It's a good question. The reason for that is because abstract figure or abstract file may have some of these operations implemented already. So I want to reuse those. And really the reason I extend it is because I want a directory to look like a file. That's the real reason, right? Because I want, like, a tool like Explorer may want to treat directories and files identically, except maybe for the little icon that differentiates them. Like getting size for JPEG file and directory, really it's the same call. I'm just calling get size on that object. So this is why it extends abstract file. The reason it aggregates file is because in general, in object-oriented systems, you want to, if you're going to reference an object, you want to reference it as far up the hierarchy as possible. So if I reference a file, then it allows me to reference everything that's below a file. It allows the directory to contain anything below this file interface. Right? If I had a, if I had a different, let's say, I implemented this interface using in some other class. Like maybe this is an abstract file, but it's a local file. Maybe I had a Dropbox file. So Dropbox file would also implement the file interface, but it's very different, from an abstract file. It's remote, it has different semantics for how you access it. So if my directory knew about abstract files but not files, it wouldn't be able to contain Dropbox files. Okay, which is why you wanted to aggregate further up the hierarchy as far as possible.
In your program, can you group separate groups?
Yes, absolutely. At least it should be possible. I haven't tried it. You can try it out. But yeah, this is one of the advantages. I mean, this hierarchy is arbitrary in depth, right? So it doesn't mean that I have to limit myself in how it looks. So I could have a drawing. So a drawing is kind of like the root of my directory, right? It's like my C drive. So my drawing knows about a circle, knows about a rectangle, and then it knows about a composite figure. The composite figure may know about a circle, but also another composite figure, right, which knows about another circle, and so forth. So you could draw a tree like this, which has arbitrary number of intermediate nodes. So this is a leaf, this is a leaf, this is a leaf, this is a leaf, right? And then composite figure is a node in the middle. And then, of course, my drawing may have multiple composite figures itself. So I might have another composite figure and maybe another composite figure down below. So really, this pattern allows me to create trees in a very simple way. And trees in a way that trees that are very flexible because I can reference intermediate nodes as if they're leaves. Okay, so the rest of the time, you can actually look at the lecture lab. So the lecture lab is posted online, and it has to do with the file system. So we're talking about file system just now. The composite pattern is great. It works really fantastically well in that domain. So check out the composite file system from the lecture repository, and then just start working down the steps. And you can get a start on this today, and then we'll continue on Wednesday. Okay? And if you have questions, just raise your hand. I'll walk around.